Channel, it is a fat Talak back with another video. So in today's video, we are going to be talking about concave and convex mirrors. So the reason why I'm making another video about this is because some people apparently did not understand the concept of it. So in the comments down below. So I'm gonna go ahead and try to make a better video, a more brief video. Apparently I'm not signed in my network. There we are. So yeah, I'm gonna go ahead and show you guys all of these slides that I have done for my concave and convex mirrors and ray diagrams. Well, this one is not the concave or convex mirrors, although these all are convex and concave mirrors. This one is just, I added this in the slides because I want you guys to really understand this, because you also need to know this in order to understand concave and convex mirrors. So like I showed in my previous video, I have this paper sheet that I've done. So I'm gonna go ahead and show if you guys can see this. This one right here is a concave mirror. As you can see, salt, it is size, the attitude, the location, and the type. So for this little diagram that I have made is called a concave mirror. I'm gonna describe this on the computer. I can't really describe on paper. It's just a bit harder for me. Although you can see all the different colors and the different ray diagrams that I have chose. My object is an apple, as you can see. And one quick little common thing that you guys are going to see all the time is the point of intersection. So in physics, you'll see a point of intersection. That's where all the rays hit and end off and intersect every line. And you'll have a point of intersection. Now, it is always going to have an point of intersection, or else you will never find the other, wherever the object reflects. So we have the object, the rays are hitting the mirror and bouncing off to an intersection. This means wherever the point of intersection meets is where the second object would be. But know this, that this is a real image. That is why we have real image for the type. As for convex mirrors, it will always be a virtual image. So it would not be real. It would be over here, the image, and it wouldn't be on the other side. So without further ado, let's get into the presentations and the slides. Sorry if my camera is kind of bad right now. It's not in a good stand. All right, so we have this little instruction sheet that I have provided. So access the simulation. Let's go ahead and access the simulation. All right, if you guys hear a little bit of background noise, it's because of my families are like watching a movie right now, so I'm sorry about that. I know I'm not the best at quality, but it's okay. I'm still getting the work done. So the percentages and the show reflected ray, we can close that down. So I'm gonna go ahead and do that. Sorry if you guys don't see it. Here it is, close those down because we don't really need that. So what we have to do now is, this black bold line is called the angle of incidence. So basically it is like the reflection hitting the surface, and then this little fading away line would be the reflecting angle. So as you can see, it says it is 61.2 degrees and 61.2 degrees for the, so it's 61.2 degrees, the angle of incidence, 61.2 degrees for, 61.2 degrees for the reflecting angle. So if I go ahead, for instance, and change this to a different degree, if I said 50, for example, it would change. You can see that it's coming a little steeper, and it's still 50-50. Now, why is that, right? So I'm gonna go ahead and change that again. Let's make it 25. Well, that's just this is going way more steeper now, as you can see, and both of them are steeper. But if you guys realize that they're both the same angle, so we don't know why, right? I mean, you can use anything, even 10 degrees. You can go the smallest, 1 degrees. It's still both the same. I want you guys to know and discern that every time you change the angle of incidence, the angle of reflection will always be the same. So the reflecting image that's bouncing off the surface will always be the same as the angle of incidence. Now, it's kind of obvious because when the angle of incidence bounces off, it will go the same direction as the angle of incidence had came to the surface. So it makes kind of sense if you think about it. So if you guys want to access this website, you guys can go ahead and do that. I'm going to go ahead and show you the link right now from hand. It's called OPhysics, Interactive Physics Simulations. If you guys really want to do that, you guys can go and free to do so. And yeah, that'd be perfect. So yeah, so you can really see that if you even do a 3-degree angle, for example, it would show you the same thing. Very steep and very, very much the same. If I went 90, it's just a straight line, right? Look at that. It's just a straight line. So that's why it's really all the same at the end of the day. All right, so we found out that. I'm going to go ahead and close that up, and we'll get back to that later in the video. My bad. Here we go. So we have a mirror right here. Now, I'm going to go ahead and present this from my angle. So if you guys can see this quite well, then you guys are great and taking notes, hopefully. So it's asking me to draw a ray diagram for the object being reflected in a concave mirror. Use SALT to describe the image that is formed. SALT, in other words, is size, attitude, location, and type. So here, this is what I did. So don't look at the Among Us thing. It's just my teacher who put that there. It wasn't me. So I labeled them by numbers because I feel like that is a better representation. So here I am starting off with number 1. So here I am, 1. So I can see that I started from the head, went all the way from here, number 1. And as for number 2, I just went right over here. Anyways, back at it again. If we go ahead and see this, this is going to be a concave mirror. Meaning, as you can see, I started off putting rays on top of the head. It's because that's where you want to start off with. So here I am making it. And this is the point of intersection. So I can't, unfortunately, zoom in. Can I? I don't know if I can, but I can't zoom in, I think, which is the sad part, but it's all right. So you can see the point of intersection right here. This means that the mirror has been hit by the object and has bounced off and made all intersections with the lines beginning right over here. So this would be in between the curvature and the focus point. That is why for L, location, I put between C and F. Okay, so I went ahead and put the point of intersection to be really like labeled out there so that they can see. So I put my image right below there. So it would be the Among Us character, green, right below right above the point of intersection, upside down. Now, this is a concave mirror. It is not a convex mirror. Convex mirror would be the opposite of this. So it would be like that. I don't know if I can draw on these, can I? There we are. So it would have been like, whoop, that's someone else's presentation. So it would have been like this. I don't know if you guys can see that with the red little thing I got there. It would have been like this, but not like this. This is a concave mirror, as you can see here. That is a concave mirror, and then this would be a convex mirror. If I could write, it would actually be really better, but I don't think I can, unfortunately. I could go ahead and do that on a piece of paper if you guys like. That's weird. Okay, well, that's okay. So as you can see here, point of intersection is where everything intersects. So that is obviously where I put my image, upside down. And then it's between C and F. So that's why it's really self-explanatory over there. So I put smaller, the image is smaller, as you can see, and the attitude is inverted. Now, concave mirrors will always be inverted. The other option is upright. Upright is for convex mirrors. Always know this. I think you guys should be really jotting these notes down because these are really important in physics. Even grade 11, 12, and 10. So this is more like a grade 10 assignment, of course, because it's not that advanced yet. But you should really get these down. These are some key points. Salt. Anyways, so the attitude is inverted, will always be, and location is between C and F. Now that can always change. So mine just had to be today, C and F between, and the type will always be real. It is always a real image because it would have gone here if it was a virtual image. All right, let's just get out of that presentation now and move. Okay, we're at old physics again, and today I'm going to be going ahead and clicking concave and convex mirrors. All right, here we are. Okay, so as you can see at the top right, it says concave mirror. This is a concave mirror, like I described. There would have been lines here, meaning this is the back of the mirror, and this is the front of the mirror. Unfortunately, I don't have a pencil to write on, so that's okay, I guess, but it's all right. Okay, so I'm going to go ahead and doodle around with these and play around with them. So as you can see, we have the focus point. We have the object, we have the CC, so curvature, and we have the image. So I can move any of them. The focus point, the image, up and down. Well, not the image, sorry. What am I talking about? I mean, I can move this, the curvature. What's going on? There we go. This is the object. I can move the object around as much as I want. I can't move the curvature. You guys should know that, all right? The curvature never moves, so you can go as much as you want. The curvature will not move. So let's just say I want to put my object over here. So now the rays are all bouncing off, and this is the point of intersection. You see? This is where the image, the second image will be, reflected. Notice that the image characteristics will always be inverted and real image, like I told you guys, right? It will always be a real image and it will always be inverted. In this case, the image is located in between the curvature and the focus point. So that is where our size and everything would be. Okay, so we learned a lot about concave mirrors over the past few videos. What if I went ahead and put my object on the right side of the graph? Well, wow, everything changes, right? Now, it is a convex mirror. Whatever the object or the focus point goes there, it will be a convex mirror. But if you move the focus point over to the right side, it will still be a concave mirror and it'll be inverted or a real image, either way. As you can see, the mirror goes away, right? Exactly. Okay. Let's just leave the focus point here. I'm going to go ahead and take my object, where is it, and bring it here. Now, as you can see, it is a convex mirror. And what are the image characteristics? Upright and virtual image, like I described. It will always be an upright or a virtual image every time the object will be on the right side of the graph. Okay, so we know that. Well, why is there dotted lines all across the left side of the graph? Well, where it gets a little interesting. The convex lines hit the mirror, but it does not go through. These dotted lines is explaining that if the convex lines did go through the mirror, that's where the lines would go. So this is the point of intersection if the convex lines went through the mirror. So in this kind of situation, what you would do is still calculate, and you would know this is where you put your image now. But this now is not a real image. It is a virtual image. So it is no longer a real image, or it is not inverted anymore. It is now upright. Okay, so let's move it around a bit more. What if I went below? What happens? Well, nothing happens. It's the same. It's still an upright image. I mean, it's still an upright attitude, and it's still a virtual image. Nothing changes. There's still a point of intersection. That's where the image will be. So don't get fooled by that at all. There's nothing that's going to change. Even if you put it at the very, very corner of the graph. Still an intersection, still an upright, and still a virtual image. Okay. And even if you put on the line, nothing happens. It's still an upright and virtual image. All right, so we narrowed that down. What if I moved the focus point over here, around here, right here? Well, now everything's on the right side. And it is always still a convex mirror. Well, where's a mirror? That mirror is not there anymore when I put it here. Well, that's because it's a straight line now. The mirror is still there. It doesn't show. So the only dotted line we have here is this, so it doesn't pass through. And as you can see here, this is the point of intersection, is where we will have our other image. So this is a bit more complicated way of doing it. If I go ahead and redo this. Excuse me. Okay, so yeah, so that is basically what we want to learn about Physics website. I'm going to go ahead and close that up because I don't think we need that. I'm going to go ahead and take out my drawing tool. Although I think this is not the best drawing tool because it's not the best, honestly. I'm going to go ahead and plug in my my mouse because I can't draw with the finger pad because it's not good. Okay. Here we are. I'm just gonna go ahead and actually, I'm trying to take the camera to a better position. Okay, this is good. I don't know if I can make my camera, I don't think I can make my paint any thicker, can I? Oh, I can. Wow, okay. I don't know that. There we are, okay. Okay, so I'm gonna go ahead and make a couple of, oh, that's not the good one. Okay, sorry, I was just testing it out. Okay. I want to see if one is good enough. That's a little too thick for on our side. Okay, we'll just use this. All right, so I'm gonna go ahead and make a gray diagram. All right, there. This is my line, and now I have to make a quick little mirror. All right. What can I use for this? Oh my God, that's my bad. Sorry about that. So I'm gonna go ahead and put my mirror right over here. All right, here I am. Wow, this is kind of hard to manage. Oops, I put the whole thing away, no worries. All right, so here I am making my line. And actually, let's make that a little longer. So, okay. All right, now I have my mirror, which I will put right here. Gosh, put my mirror right here. All right, now I'm going to move it right. Oh, God, this is hard. Okay. Wow, apparently this is not working for me. All right, well, let me try with these. Let me try with this. Okay, that's weird. Huh. Maybe. Okay, well, that's okay. I am going to, this is already looks like a mirror, it's bent, so it's okay. Okay, so now I'm with my brush, and I'm going to go ahead and use and make my line of, oh, that's one point, and that's another point. Okay, so now we have a ray diagram. We're not quite done yet. Now we have to make the points. So here, it's the focus point. So let me go ahead and write this down with my finger. With my tab. The F point and the C point. So the curvature. Well, those are pretty big. That's not good. Let me go ahead and fix that up. I wonder if you can type in this one. Oh, that's okay. So I'll go ahead and make my F, and I'll go ahead and make my C. All right, fair enough. The point of the curvature, and the point F. Okay, perfect. So apparently I could write. Oh wow, okay. Okay, guys, sorry about that. That is my bad. All right. So here we have point C and F. And if we go ahead and close this down, we have the O physics. Sorry, it's not on here. It's on my other doc. Let me go ahead and bring that out. O physics. Oh, physics. There we are. And wrong one. Concave and convex mirrors. All right. So this is how we get our points. So we have our focus point, we have our curvature, and now we want our object in an image. Now, most of the times we'll just pick an object. It wouldn't be a image. So here, I am just going to write the object. So let's make the object let's make it a star. Sorry for the bad drawing, but this is the object. So I'm just gonna go ahead and do the, the normal. Go ahead and erase this very quickly. I'm gonna go ahead and type this out with my words instead. I don't like drawing it. It doesn't look really too formal on that point, but okay. So we deleted that. Let's go ahead and bring this out. This is the point C, and this over here is point F. All right. So now we know right over here. Perfect. Okay. Point C and F. Sorry if I'm trying to make this perfect, guys. I just want you guys to see it perfectly, or else, Apparently, well, this tool is not good to use. I'll probably use another thing on it. Okay, anywho, point C and F. Hopefully you guys see that well. And that is my object. So for this one, I'm just going to write OBJ. All right, that's my point of object. And this is my mirror. So yeah, let's go ahead and make our rays. So I start off the top. Oh my god, this is getting really annoying. I'm gonna start off the top and hit the ray. Okay, so I hit the line. I'm at the mirror, and now my point is gonna go through the focus point and end off right here. Now this is going to be number 1. That is number 1 line. The second line is going to be hit by this again. Oh, not good, not good. It is going to be hit by the focus point and it is going to go, oh my God, here he is. And it is going to hit, oh, what's going on? This is really, really, really getting frustrating, eh? It is going to go through F, and it is going to be, apparently I can't write on it. Oh, there we are. And it's going to go through like straight ahead. All right. So then that over here is going to be our second mark. Okay, so we have that done. We have two rays. We have two little reflecting rays. Moving on to the third one. This one is going to go straight down and hit the mirror. Now, it does not bounce off. This one does not bounce off. So we're gonna go ahead and write this as number 3. All right. Now for the last and final ray, for number 4, this is going to hit the center of the mirror. So here I am, starting from here and hitting the very middle of the mirror. Okay, so now what do I do? Now, it's not gonna hit the focal point, the focus point or focal and a curvature at all. It is just going to go through just like so. So here I am, going through and ending off right over here. All right, so now that this is going to be number 4 of the graph. Okay, well, we're done. So now we know the point of intersection. Oop, it's this right here, right? Correct, right? So this is the point of intersection. All four of these ray reflectings from the mirror ended off here. So in this case, we would write the point of intersection is between C and F, or C and F, or if you want it to be a little bit more formal, you can just say curvature and the focus point. That's how I would write it. So the point of intersection is between the curvature and the focus point, meaning the image will appear below the line. Okay, so the point of intersection is between the curvature and the focus point, meaning the image will appear below the line. And if I go ahead and move this whole entire text box, put it right here. Oh, apparently I can't put the whole thing there, I think. I don't know if I can actually put it there. Can I bring it with me? Okay, well, interestingly, I can't, I think. Anyways, and that's my answer to the question. Now, if I wanted to be a little bit more fatigued and on it, I would go ahead and make a point of intersection. So here I am, making a little black dot. Point of intersection. So I can go ahead and even label that. Point of intersection. All right, point of intersection, and here it is. All right, yeah, so now we know that this is the point of intersection, and now this is where the image will appear. So here is my star. Sorry about the bad drawing. So yeah, guys, That's basically the only things that you need about this. On finding out what a concave and a convex mirror is. This is a quick little example. I think showing this would be a better explanation, although, because it just seems more to be more straightforward. So if you guys want to go ahead and copy this down on a piece of paper or something, it'd be pretty good for you guys, I think, as a lot of things. So if you guys didn't know that a concave mirror is a converging mirror and a convex mirror is a diverging mirror. So yeah. That is all about concave mirrors and convex mirrors, although I will probably do a different video for the convex mirrors. I've talked a lot about concave mirrors today, that I feel a little guilty for not talking about the convex. But yeah, I'll go ahead and make a video for that. So hopefully this video helped you guys a lot. I really hope it did, because I love helping people out, and I just really do hope this helped everyone who's watching this video. I'm going to go ahead and download this video just in case. So I'm going to go ahead and call it physics, let's say grade 10. Yeah, it is grade 10. So grade 10 physics grade 10, concave and convex mirrors. All right. Okay, guys. That's going to be the end of the video. I hope you guys enjoyed and had a great, a great experience learning about this. And I hope you guys, hope you guys took some notes down, because these are some really good points that I've pointed out in the video. So if you guys do enjoy this video, please leave a like and subscribe, and comment down below if you guys have any suggestions for me. And just one more thing, if you guys really want this website, it's just called ophysics.com. Yeah, I'll leave it in the description below. So peace out, have a nice day, and yeah, I'll see you in the next one.